Hey, what's up, guys? John here. So today, let's take a look at uh, number 763, partition labels. Okay, so you're given like a string, very straightforward. You're having a string here, and it asks you to partition, right? Partition the strings into as many pieces as possible, uh, which where in each of the partitions, right? Basically each of the character will appear in only one partition. Basically, after your partition, you cannot have one letter that appears in more than one partition. So, for example, this one, right? So, I mean, you partition it to A to A and A. So all the A's are in this partition. All the B's are also in these partitions. Okay. Same thing for the D, E, F for the second one and for the third one. So that's why the output, okay, yeah, it asks you to output the length of each partition. Okay, yeah, and so and you can of course have a big partition, right? Basically, you can always only have one partition which includes everything, but it asks you to include to partition it as many as possible. Okay, so. mm, So how can we solve this problem, right? I mean, I think every time, when you ask you to find like the maximum number, you know, I think you guys maybe you can always try to think about, can we solve this problem with binary search? At least that's what I do. Every time when I have like a problem in front of me, I think first thing I'm to my mind is, can I solve it with binary search? Okay, so but probably for this problem it's not, right? Because it's not asking us to find the minimum. Sorry, the numbers here, the total number of the partitions. Instead, it's asking us to find the length for all the partitions. So we cannot use binary search. Mm, if you watch this, like if you watch those kind of strings closely, right? So the way we're doing it, basically, when we have an A here, right? Basically, we scan. Let's say we have an A, B. Uh, No, let's take another example here. Let's say the DE here. Uh, DE, F, E, G, D, E. Okay. So when you scan this string from left to right, okay. So when you scan the first D here, right? And what kind of information you need to know? You need to know actually the last index of the D here. Let's say the last index here is 5, right? 0, 1, 2, 3, 4 is 5. Basically, you need the last index for the current numbers. Okay, and now if you move to the next one, you also need to check, right? So what's the last index for this like character? In this case, it's 6, right? That's then we need to, okay, then we know, okay, so we need to update our last position. Okay, until what? Until these two pointers are the same. Okay, now the last index for f is like is 2. 2 is smaller than 6, then we don't need to do anything. So E, same as 6, don't do anything. G, D, right? And then E. So by the time the slow pointer and the last position, they are the same, then we know, okay, we have find this one group here, right? And then we just move, once we have defined a group, we just move the start point to the next one here, right? So basically, this is kind of like a greedy idea here, right? We're trying, basically, we only expand this group when we see a later ending point of the current ladder. Okay. So, and in order to do that, we need to pre-process all the last position for each of the letters. Okay. So let me code these things up here. So last positions. Okay. Uh, so the way we're doing it, like the value will be the the key will be the character, and the value will be the index. Okay. For I and the character in enumerate s, right? Basically, that's a, a shorter way of doing the for loop here. Basically, so if the C appears multiple times, it will always be overridden, right? So by the by the le the letter by the later index. So by the end, we have processed all the strings, all the letters in S here. So what's left is the for each letter, what's the last index for that? Okay, cool. So given that, we can start looping the string here. Start equals to 0. Yeah, and then we have a current stop. Okay, we have start and stop equals to 0 as well. So basically, for I and character in enumerate s. Okay, max stop. Okay, we have a current stop. Current stop equals to what? To the last position of the C here. Okay. If the current position, basically we just update that, right? Update the max stop is the max of the is the current stop. Okay. So I basically every time when we have a new stop, we'll try to update this max stop to keep. And okay, and if I is equal to the max stop, basically if we there's no need to expand this current group anymore. Basically, if the current I has reached the end of the group, then we know, okay, we have find this partition, right? And then we just do a answers dot append. We're gonna need to append the uh, max stop. Okay, max stop minus we can either use I or max stop minus start plus 1. Okay, and then since this current group is finished, we just need to move the start to the current I plus 1, right? Okay, and then in the end, we simply return the answer here. Yeah, I think this should just work. Okay, run it. Current stop. Okay, yeah, cool. Yeah, I think, yeah, that's pretty much it is, right? I mean, so for the space and time complexity, right? So time O of n, and here it's also a O of n, right? Is also a for space is O1 actually, because the letters they're all lower letters. So basically we'll have like at most 26 elements in the last stop. Uh, yeah, that's the so for this last stop it's a O26, which is O1. How about the answer here? So the answer is A, B, C. Yeah, so for the answer, it's also like O of 26. Yeah. right? Because we will have at most like 26 groups, okay, for the answer. That's why the space complexity is like it's O1 and the time is ON. Okay. Yeah, so just to recap, right? Basically, I mean the key idea for this problem is that we just need to know like what's the last index, what's the last position for each of the character. And once we know that, we can simply uh try expand the current group, okay? And we only expand it when the current stop is greater than the max stop. Okay, and after expanding the group, and if the current index is the same as our stop, then we know okay we're at the end of our group, and there's no need to expand it. Then we can simply save the current length, right? The length of the current group to the answer, and then we move the start to the next position to get ready for the next group. Uh, cool. I think that's it for this problem. Yeah, it's pretty straightforward one. Yeah, but I like it. Thank you so much for watching the videos, guys. Stay tuned. See you guys. Bye bye.